Hello there. This is my teaching video for Done School Application. Um, so I'm going to be talking about Pythagorean theorem, but before I start, I want to say that this isn't exactly how I would make a video normally, right? I would be wouldn't be having breaks or whatever. And what I would do is, well, you'll see, but I'm going to do like I do an example, they do an example, that kind of format. And normally what I would do in a video is I would just do several examples in a row. So it's not exactly how I would do a video. It's more how I would do a class. So if I was in class, what I'd want to do is I do a little explanation, I do an example, they do an example. I do another little explanation, I do another example, they do another example. That's my usual style for doing this. So that's going to be, obviously, I don't have any students doing that here. So that's going to be the general format. So let me get started. So today we want to talk about the Pythagorean theorem. And I'm assuming this is kind of introducing the Pythagorean theorem. Oh, by the way, I should say that I'm assuming students have access to a calculator and that they know what square roots are, because we're going to be using defined distances, of course. So I'm just taking those things for granted. I don't know exactly where we're going after this, but I'll have a little bit of a discussion afterwards anyway. Okay, so let me get back to the point. So today I want to talk about the Pythagorean theorem. So let me show you your worksheet. Oh, I suppose I should probably say that usually when I do this in front of a class, I'll give them a worksheet that's the same as the one that I'm using. I'll project it on the board and do stuff on the worksheet, and then there will be room for them to do the same things as notes, and also for them to do the problems that we're working on their worksheets, and then they just keep them, and that way they sort of build up a series of like reference materials that they can use over and over again if they want to. But anyway, that's the way we would normally do this. So here is, let me share my screen. So this is the worksheet that we're going to be using. So yeah, Pythagorean theorem. So the Pythagorean theorem is surprisingly powerful and also very simple. It's really interesting in that regard. All it does is it gives us the relationship between the lengths of the legs of a right triangle and the hypotenuse of the right triangle. So just a quick refresher, the legs are the two shorter sides and the hypotenuse is the longer side in a right triangle. That you can identify the hypotenuse because it is across from the right angle and the legs are the other two sides. The relationship is this one: a squared plus b squared equals c squared. A and B are the legs and C is the hypotenuse. It doesn't matter which leg is A and which leg is B. You can always label them either way, or you can switch them if you want. But C, you do have to have the hypotenuse be C. The longest one has to be C. So Pythagorean theorem only works with right triangles, but there is a more advanced version called the law of cosines once you know trigonometry. But that's a later class. So let's do an example. So I want to find X. I'm going to find how long this side is. Notice that what I'm looking for here is a leg, right? I have a hypotenuse and a leg, and I'm looking for the other leg. So what I want to do is this. I'm going to, let's see here, a little rusty at this. So the equation that I can write is one leg squared plus the other leg squared equals the hypotenuse squared. So I can say that x squared, that's not a great squared, plus 3 squared equals 5 squared. And then all I have to do is solve that equation. So I've got x squared plus 9 equals 25. Subtract 9 from both sides, and I get x squared equals 16. And taking the square root, of course, we see that x is 4. That's Pythagorean theorem. That's really as simple as it is. There's not much more to it than that. All right, so normally what I would do is I would pause for questions here. I don't think that's going to be necessary in this case. Let me see if I can. Sorry, they've changed the controls here, it looks like. How do I erase all this? No, not like that. Like this. All right. All right. So that's the basics of Pythagorean theorem. And then what I would do is I would have them do the next one. Stop annotating. I apologize. This part is always a little awkward on Zoom, and I don't really have a better way to make videos. So yeah, that's what I would do in a regular video. In a normal classroom, it runs a little smoother. So here you go. Here's the problem for them to do. And I would wait for, 2 minutes, something like that, for them to find the link to the hypotenuse here. And I deliberately left an error in this, not an error, but a thing that I wanted to point out, which is there's no right angle here, right? In the other ones, you can see there's right angle. And I'm hoping they will see that the thing that's wrong with this diagram is that there's no right angle here. And so we can't really be 100% sure that's a right triangle, even though it looks like one, right? This angle could be 91 degrees or whatever. Yeah, I just wanted to take that opportunity to tell them to be really picky. Once they're done with that, then I'm going to talk about this. So the Pythagorean theorem is super, super simple, right? It's literally just that equation in right triangles and tells you, seems like, a little bit of information. It turns out that the Pythagorean theorem is unbelievably powerful. Like it's used in so many areas. And I know that sounds like an exaggeration, but it's not. Anything having to do with distance, Pythagorean theorem is incredibly useful. And I could go on and on and on about the various uses here, but I just want to show a couple. So here is the first one. I want to find the distance between these 2 points, -2, 1, and 6, -5. And this does not seem like Pythagorean theorem at first, but of course it is. Right? So what I'm going to do is I'm going to graph these points. So -2, 1, and 6, -5. So we'll do this. I'll just make a little graph. So -2, 1 is something like here. That's not great. 6 -5 is over here. Right? And so what I want to do is find the distance between those 2 points. You might say to yourself, well, I don't see a right triangle. Well, let's draw one. That's the power of Pythagorean theorem is between any 2 points, you can always make yourself some kind of triangle, right? So I'm going to draw a triangle that looks like this. And then the distance between those points is right there. I'm going to call that D first. D is the distance between those 2 points, right? So this was -2, 1. That's this guy here. And then 6 -5 was this one. So now the question is, okay, I've got a right triangle, but how long are the legs? Well, we can subtract to find out. So the question really is like, how far is -2 away from 6? Right? And we can just see that we can just count if we want to. We can also just know that that's 8, right? It's -2 up to 0 and then 6 more over to 6. So that's 8 here. If you want to do that formally mathematically, you would do 6 minus a -2 and get 8. So in general, if you want to find the distance between things, you're probably going to be subtracting, and that's going to be relevant later. And then the other one, we got 1 and -5, and how far apart are those? Those are 6 apart. So this leg over here is 6. So what I really have here is that 6 squared plus 8 squared equals D squared. So that's 36 plus 64 equals D squared. And so that's 100 equals D squared, which of course means that D is 10. So that's just 2 random points on the plane. I can do this with any 2 points I want. This is one reason why Pythagorean theorem is so powerful, is I can just draw an appropriate right triangle to find the distance between things that I like. Well, that I'm looking for, I should say. And we get this. So I want you guys to try one. And so, of course, what I would do is I would have them try one here. They're going to try the next one while I erase this bit. And of course, in class, I wouldn't erase this. I wouldn't be erasing this now. I'm just doing it for the video. Let them look at it while they like when you're learning, you want to be able to copy. Copy is like the first part of learning, right? So you can see what someone else did. So I like to leave that up there, leave my work up there while they work on theirs. So there's really no chance of them getting stuck. They're just kind of getting the experience. So they would do problem 2 here. And then what I want to do here is after we've done a couple of problems, I want to stop and have a discussion. So in class, what I would do is say, okay, I want you guys to get into groups, or they would probably already be seated in their desks. I saw that the curved desks that we have. And within their groups, I want them to find the relationship between the triangles in example 1 and example 2, and also between problem 1 and problem 2. And I don't know if everyone caught it, but they're twice as big. The ones in example 2 and problem 2 are twice as big as the ones in example 1 and problem 1. And here I want to talk about what Pythagorean triples are. So everything's been working out in integers so far. That's not normal for a Pythagorean theorem. In general, you get a lot of decimals because you're taking square roots, and those don't always work out nicely. When it does work out nicely, when you have 3 integers along a right triangle, or along the sides of a right triangle, you get what are called Pythagorean triples, and those are really useful. So for when they're studying for standardized tests, Pythagorean triples are very, very useful. These are common uses, or they show up a lot on standardized tests. Here's some common ones. The ones that actually show up on tests are 3, 4, 5, 5, 12, 13, and occasionally 7, 24, 25. Not super often. They standardized tests, in my experience, don't really use any other ones, although they obviously could, right? But those are like those, the first one is incredibly, incredibly common. This is somewhat common. This is occasionally useful, and I don't think I've ever seen another one. So yeah, the Pythagorean triples, really helpful for standardized testing. So I would hope they would come up with this relationship here. I would imagine it won't be too much of a challenge for them. And then I would ask them a question here. Do you think that's always true? Is it always the case that if you take a Pythagorean triple and multiply everything by something, so you multiply it all by 2, or you multiply it all by 3, or you multiply it all by 10 or 100, do you necessarily get another Pythagorean triple? And I want to seed this in their brains because I have a challenge question about that. All right. One more example, then we're done. Then we're going to talk some challenge questions and be done. So we've got Camille and JP are walking home, and they're walking home together. They arrive at an intersection, and Camille continues north while JP turns east. So they're going north. Camille continues going north. JP turns east. Camille walks at this rate, 2 feet a second, and JP walks 1.5 feet a second. And how far apart are they after 1 minute? So, a couple things to consider here. One, these speeds are in feet per second, and I've asked about minutes. So be really careful with units, especially when you're dealing with speed, and it's very easy to mix up the units and speed. And 2, are these numbers 2 and 1.5 setting off alarm bells in your head? And they should be. Why? And I would let them ponder about that, and hopefully someone will tell me that this is half of 4 and that's half of 3. So we've got a classic Pythagorean triple here. So I want to know how far apart they are after 1 minute. Well, like pretty much every Pythagorean theorem problem, we're going to draw a triangle. So let's do that. Get to annotate here. So Camille is walking 2 feet per second north, and JP is walking 1.5 feet per second east. So we've got here's their starting point. Sorry, my screen's a little dirty here. Okay, and then Camille goes 2 feet per second this way, and JP goes 1.5 feet per second that way. Right. 5 per second and 2 feet per second. This origin it's not going very well. Anyway, whatever, you get the idea. Okay, so I'm hoping that everybody saw that this is going to be a 3, 4, 5. So what I want to do is talk about what's an easy way to calculate this, because we can certainly calculate this with the calculator, but what if the numbers were really bad, right? Okay, so I'm going to draw a triangle. Oop, nope. Hey now. Don't move. There we go. There's my triangle. Right. So I've got this guy here, and I want to know how far apart they are. Okay, well, after 1 minute, that's 60 seconds, Camille has walked 2 times 60. It's 120 feet. Right, so this is actually 120 feet here. And JP after 60 seconds, if we do 60 times 1.5, we'll get 90. This is 90 feet. Now, we could jam this into a calculator, but there is a better way. And the thing I want to point out is this. We know this is going to be a 3, 4, 5 triangle, right? It's a multiple of a 3, 4, 5 triangle, and this is going to work out that way. After 2 seconds, JP has gone 1.5 times 2, which is 3 feet. And after 2 seconds, Camille has gone 4 feet. And so the distance after 2 seconds would be 5 feet. However, we've got 90 and 120, but that's just 30 copies of 2 seconds. So the distance is just going to be 30 copies of 5 feet. It's going to be 150 feet. So I would have them plug this into their calculators, the 90 and the 120, do 90 squared plus 120 squared, and then take the square root of that, and it would turn out to be 150. Magic. Right? So this is going to be 150 feet. So here's my pitch to you. Especially on standardized tests, look for the number. Don't just like passively take in the numbers, but be thinking to yourself, that looks like a 3, 4, 5 triangle. I bet this is going to be really easy, and I probably don't even need a calculator. Like, this is 3 points. Right? That's a thing that I really want them to see, is that once you're good with Pythagorean triples, you see them everywhere, especially on standardized tests. So there we go. That's how we can do this. We're gonna do I would do another have them do another problem. Very similar. It's a dog and a rocket. Rocket goes up, dog goes horizontally, find the distance. And this is an 8, 15, 17. So this one ends up being 34. Okay. That's it. That's my lesson on Pythagorean theorem. But one thing that I always love to do is have some challenge problems. I love when students have some optional problems that are interesting. Maybe depending on how the grading works out, I might use these as extra credit, or I might use these as discussion questions. And depending on how much time I wanted to spend, I might have them work on like maybe number 1 and number 2 in groups potentially in class, or I might make it like a challenge problem on homework. So I always have a couple of these for pretty much every topic. Here are the ones I came up with for Pythagorean theorem. I would at least want, like with the students, I would at least want to talk about these. So prove the relationship in the discussion question always holds true. So a multiple of a Pythagorean triple is always also a Pythagorean triple, which is true. That is the case. So can you prove it? And this is my pitch to get them interested in proving stuff. So I would probably want to make these worth some kind of points and allow them to work together. And this is another thing that I might do for like a presentation. I might let somebody present to the class for extra credit, something like that. And we've got a bunch of problems here. These are definitely like so 3 is probably a little much for like in class if I've only got 50 minutes. But this is definitely like if I wanted to spend a lot of time, we would do something like 3. Or if I wanted to have a kind of a big extra credit thing, I might lead number 3 into like a larger discussion of circles. But that's it. That's my teaching demonstration. So thank you very much. I hope you enjoyed it. Let me know what you think. Alrighty. Bye-bye.